I'm out here taking a walk and talk with one of my good friends, Saima Ansar, who is a researcher and group leader at Lund University. Saima, thank you.
Thank you for giving me the opportunity to have this walk and talk with you.
Thank you. I was thinking, you did your master's degree in Copenhagen and is actually a trained pharmacist.
Yes.
So how come that you ended up with research in the stroke area?
Yeah, during my master in pharmaceutical science in the last semester, we have to do a 6-month research project. And at that time I had a huge interest in pharmacology and physiology, and I wanted to go abroad. So this was the only 3 things I knew that I wanted to do, and then I got an opportunity to do a master thesis at the UC Irvine in California in US. So I went there, but at that time I thought I would just do my 6 months research and then I will probably go to the industry. And then I got into a really nice research group, and somehow it's catched my interest. I thought it was fun. And this thing that the knowledge is a never-ending story somehow. There is always more to learn. I mean, it's not like, oh, now we know everything. And the atmosphere and the lab and everything was also, of course, the environment was nice. We worked hard, but no, So
that sparked your interest in research?
Yeah, and that was the time I actually decided I wanted to go for a PhD.
Okay, but it was not written in stone, it was not something that you had considered before this moment?
Actually, not at all.
What is the potential of stroke treatment now? How's the potential? Is there?
I will say that we are quite good in still saving the patients.
Yeah.
But giving a stroke patient a good quality of life is still a huge problem.
Okay.
Because even if you survive a stroke, today it's only, I will say, 10% that can go back to a total normal life. And then there is different what you determine total, and I mean that you are have the full capacity to live your life as you did before. So there I still think we have huge potential to actually, how can we stimulate that recovery phase? To actually more, how can we boost it? So maybe if you say today that a patient needs some help in the home, couldn't you make that they need no help in the home?
Yeah.
I mean, it's small things, and I think one thing is the quality of life. And it's not just for the patient, it's actually for everyone, family and friends and close by, and then on the society as well. I mean, the main thing is how we improve the life quality, but it's also a huge cost on the society.
So it's really, for you, it's also about helping these patients to a better life by being able to treat them better pharmacologically, or?
Yes, mainly pharmacological. And it's also, so I think I have 2 aims if we talk about the stroke area, and that is, one is aim in the acute phase, because today we are using thrombolysis as acute treatment, but that also have many limitations and restrictions, because you need to treat within 4.5 hours. Otherwise you have a lot of risk, like hemorrhage, bleed, and other risk factors. So one part is actually of my research is how can we actually prevent this hemorrhage or side effects that exist with the existing treatment.
Do we need to understand the brain better, or do we need to understand the vessels of the brain better?
I mean, the brain is complex, and I think it's very important, specifically in the stroke field, that it is a vascular disease, and it happens in the vessel, and then we affect the brain. And since I'm coming from the background being a vascular researcher, then it's become very natural for me to then look on the whole concept. I mean, not cutting one piece off.
Yeah.
Looking both on the vessels, the connections that they're taking into the neurons and the brains, and so on.
And how do you do that? I mean, that must be quite complex to do. Do you do it in imaging or in samples?
I mean, it's complex, but there again, I think it's very important that we try to do it with a lot of different methods.
Yeah.
And I use a lot of imaging, and I also use a lot of MRI. There is two aspects that's why I think it's important. I mean, we can follow them live.
Yeah.
So we can actually, so we can see over a long time of period with repeated measurement,
yeah,
what's going on in very detailed form, and we can see both on the vessels, on the brain, we can see on all different tissue. So from an ethical point of view, it's also more advanced, because before we needed a lot of animals to see the same thing.
Yeah.
Now we can follow them. But I think the major advantage by following is one part, but this is a standard routine in the clinic.
Yeah.
And whatever we do, we want to have a translation.
Yeah.
And I think that is probably also one thing that has been one of my major interests. Whatever research question I am tackling, it has to be clinical relevant.
Yeah.
So I take most of the time my question from the clinic back in the lab and see how can I try to answer this, and then back again.
Yeah. So it's very patient-centered questions.
Yeah, and that is an interest that catched me from the beginning, because when I wanted to do my PhD, I wanted to have a more clinical relevant question and models to get closer to the clinic.
Yeah. All right. Well, yes. Context. The future of stroke research. Where is that heading? And where do you see the big sort of challenges ahead?
I mean, if you consider that the golden standard treatment for stroke was in 1995-96, and this is the thing we still use in the clinic.
It is?
Yes, the thrombolysis, the TPA. And there's been a lot of research on stroke, and also for improving or stimulating the recovery phase. A lot has been done there as well, but rehabilitation is still the best proven. We don't have something more to boost it. So where I think there is several challenges. One is that, but that is changing nowadays. Before, people, I mean, even if it's a vascular disease, people looked very much maybe just on the brain, and we didn't see it as a whole complex.
So it's an ecosystem almost.
Yeah, and then I also think we need to understand that it's a complex disease with different things happening at different time points.
Yeah.
So I think we cannot treat it with one single compound, because if you have a lot of different things going on, you cannot just block one thing.
Okay.
And I think we need to think broader there.
So stroke potentially is a multiple diseases, not just stroke, but because the background, is it the same type of patients that get stroke, or is it?
I mean, now you're touching the background, but I think if you go away from even the background and just look at stroke itself, there is a lot of different things going on in the acute phase and then in the chronic phase and so on. So we need to think on what is happening. I mean, we have been understanding the pathophysiology now, but we are still not treating it in cocktails or different aspects, and I think we need to advance much more there. And then of course when we come to the research we are doing in the experimental part, I mean, I think it's important that we take in all aspects. How does a stroke really look like in the patient, and try to mimic that situation. And of course that can be difficult, but there I think we need to think also in a more collaborative manner. That and I think this is important to be able to tackle some of the challenges, and it's not just in the stroke. I think in every research and every aspect we need to collaborate much more, because technology is advancing and we cannot be expert on everything, but we need to take advantage of the fast road we have and the things that we have available, and I think also think that we are all working towards the same aim, and then how to get there. I mean, you cannot run the marathon always alone.
No.
You need to have partners that are good at different things. So I think,
is that what drives you as a scientist?
I love to work in good collaborative projects because it's so enriching, and it's also, you see how the project move forward, and you can also see the results of it. And as a lonely player you will never ever be able to achieve the same as in collaboration. And now I think maybe it was different 20 years back, but with the technology we have today, we need to also not just collaborate with people in our own field. We need to be close to the clinician,
of course,
because they are dealing with a clinical problem. The patient, they understand how does it look in the clinic. We as a researcher, but also a lot of people from the physics, technology, engineering, because they have a totally different background, but it's becoming very important in the day-to-day research. And also because we are talking about, one thing is diagnosing, following up, but all this technology, this coming from the engineering area. So that is also what drives me, to have this broader project where you are a piece of one part of knowledge, but together we achieve something much more.
That sounds, it sounds really cool, because we can only be experts in a little bit, but we can be curious of many fields and be able to communicate across fields. It's always...
So I mean, you asked me, you work on the stroke area, but stroke is becoming just one small part right now, because by having this collaboration you open up to so many different areas, and actually you also open up to different kind of diseases, and you suddenly see that maybe one thing that I'm studying, it's actually applicable to other diseases as well. And I think also there the body is connected, no? We don't cut off one piece. It is, and I'm coming from the vascular background, I mean, it's quite important for me to, the vessels are connected the whole way through. So I think that is also some part where I don't need to be expert in just one small area. I prefer to be maybe not super expert, but very broad and covering more, like something that is really touching the society as well.
Is there anything that you'd like to add about inspiration? Because we often talk about what inspires us.
Inspires. I think the thing that inspires me is when you sit back and think about the impact certain things can have, and there's again coming back to it drives me, even if I know it's a small puzzle, in the big puzzle, but just have the possibility to make an impact on a person's quality of life or something that is affecting the society. I think that drives me.
Yeah.
And secondly, to do that with people that have the same drive and motivation, that drives me even more.
Well, thank you, Simon.
Thank you, Ulrike.
And I will put some notes to your publications and stuff like that so people can find you in the notes.
Thank you.